The air around you has weight and it presses against everything it touches. That pressure is called atmospheric pressure or air pressure. It is the force exerted on a surface by the air above it as gravity pulls it to Earth. To further understand air pressure, let me show you the egg in a bottle experiment. When air is hot, it expands. When air cools down, it contracts. And when the egg is placed on top of the bottle, it seals the bottle, and the fire eventually goes out. As it cools, the air contracts, and the pressure inside the bottle becomes less than the pressure outside. Then the higher outside pressure pushes the egg into the bottle. We all know that the Earth is surrounded by an envelope of air. This is the atmosphere. And the atmosphere is divided into different layers, as shown in this image. The air on the atmosphere exerts pressure on the Earth, or we can say, on the Earth's object. This pressure is called atmospheric pressure. Atmospheric pressure drops as altitude increases. Earth's gravity pulls air as close to the surface as possible. As altitude increases, the amount of gas molecules in the air decreases. The air becomes less dense than the air near to sea level. This is what meteorologists and mountaineers mean by thin air. Thin air exerts less pressure than air at a lower altitude. Atmospheric pressure is commonly measured with a barometer. In a barometer, a column of mercury in a glass tube rises or falls as the weight of the atmosphere changes. Meteorologists describe the atmospheric pressure by how high the mercury rises. Do you want to know why your ear pops in airplanes? As you go up in an airplane, the atmospheric pressure becomes lower than the air pressure inside your ears. Your ear pops because they are trying to equalize or match the air pressure inside and outside of your body. The same thing happens when the plane is on the way down. Your ears are trying to adjust to a higher atmospheric pressure. There are highs and lows of air pressure. A higher pressure system has higher pressure at its center than the areas around it. Winds blow away from high pressure. Swirling in the opposite direction from a lower pressure system, the winds of a high pressure system rotate clockwise north of the equator and counterclockwise south of the equator. This is called the anticyclonic flow. Air from higher in the atmosphere sinks down to fill the space left as air is blown outward. On a weather map, you may notice a blue H denoting the location of a high pressure system. A low pressure system has lower pressure at its center than the areas around it. Winds blow towards the low pressure and the air rises in the atmosphere where they meet. As the air rises, the water vapor within it condenses, forming clouds and often precipitation. Because of Earth's spin and the Coriolis effect, winds of a low-pressure system swirl counterclockwise north of the equator and clockwise south of the equator. This is called cyclonic flow. On weather maps, a low-pressure system is labeled with red L. High-pressure areas usually are areas of fair and settled weather, whereas low-pressure areas cause active weather, forming clouds and rains, and also severe weather.